Hey guys, today we're going to be looking at products of prime factors. So in order to understand products of prime factors a little bit better, the first thing I'd like to just recap with you guys is what is a factor? So a factor is a number that can divide into another number. So if we take the number 12 for example, all the factors of 12 would be the numbers that can divide into 12. So if we look at 12 specifically, 1 would be a factor, 2 would be a factor, 3 would be a factor, 4 is a factor, 6 is a factor, and finally 12 is also a factor of 12. Right, then we have to understand what is a prime number. So a prime number is a number that only has two factors, and those two factors have to be 1 and itself. So if we, for example, take 12, 12 is not a prime number because it's got 1, 2, 3, 4, 5, 6 different factors. Therefore, 12 is not a prime number. If we have a look at the number 1, the only factors that can go into 1 would be 1 and itself, which is 1. So therefore, 1 also does not count as a prime number. However, if we have a look at the number 2, the number 2 has got two factors, 1 and 2. Therefore, we can say 2 is a prime number. Let's try the same thing with 3. So, what numbers can divide into 3? Well, firstly, we have 1 and 3. Those are the two numbers that can divide into 3, making 3 a prime number. Wonderful. Let's go have a look at 4. What are all the factors that can divide into 4? Well, we've got 1, we've got 2, and we've got 4. Therefore, 4 is not a prime number because it has 1, 2, 3 factors. All right, so if we go look at the prime numbers in general, the most common ones that we often work with is 2, 3, 5, 7, 11, 13, 17, and 19. All right, there are obviously ones that are bigger, but these are the ones that it would do you well to know them off by heart. 2 is the only even prime number. All the other prime numbers are always odd numbers. 2 is also the smallest prime number that we have. If something is not a prime number, it has a name, and that name is a composite number. So anytime something is larger than a prime number, we call it a composite number. Right, so let's say I want you to go find the product of prime factors. So the product of prime factors for the following numbers. Let's start off with 100. All right, what we do with this is we always go draw it as a little tree, or rather as a little table. Then we have to go choose the prime numbers that go into 100. So just to remind us, I'm going to write the most common ones here at the bottom. All right, so I like to take the biggest prime number that I can see here to go into 100 just to make the process go a little bit quicker. And the largest prime number I can see here would be 5. And 5 divides into 100 20 times. Now I have to pick a prime number that goes into 20. So I'm going to choose 5 again. And 5 goes into 20 4 times, which means 2 is then a prime factor of 4. And 2 divides into 4 and twice. And 2 can divide into 2. And once I get 1 here, I know I am done. So these numbers here are then the prime numbers that can go into 100. So when they ask us to write it as a product of prime factors, we are going to write it like this. we are going to say 100 is equal to 5 times 5 times 2 times 2. The other way that we can write it is to say 100 is equal to 5 squared, because there are 2 of them, times by 2 squared. Right, and that is how we write it as a product of prime numbers. Now, this becomes useful when we want to, for example, determine the HCF of two numbers. So the highest common factor between two different numbers. If they, for example, ask us to find the highest common factor between 12 and 18, we are going to start off, number one, by first determining the product of prime factors for each of those numbers. So we're going to start off with 12. And we're going to say a prime number that can divide into 12 is 3. It goes in 4 times. 2 can go into 4 twice, and 2 can go into itself once. So if we had to write 12 as a product of prime factors, it would be 3 times 2 times 2. Now I'm going to do the same thing for 18. So 2 can go into 18. 9 times 3 can go in there. And that means 18's product of prime factors would then be 3 times 3 times, times 2. What I want to do now is I want to make the groups that they have in common. So both of them have a 3 and both of them have a 2. So the next step in my HCF formula is to go and make groups that they have in common. So what do they all share in common? Now, all I'm going to do is say to get the HCF of 12 and 18 is very simple. It is just 3 times 2, which means the answer is 6. All right, let's try another one with 3 numbers this time, just to make sure that we completely understand the concept. If you are in high school, it's very likely that your teachers are going to allow you to use your calculator, which in order to determine the product of prime factors, you're going to put 18 in your calculator. You're going to press equals. Then you're going to press the little shift button at the top, and then you're going to press fact. Right, so fact is on the Casio calculator. It is seen at the top of this button. Right, so you would basically press equals, shift, and then fact. And the fact button is this one. You'll see it's right at the top there of that button. All right, so let's try another one. Let's say I want to know the HCF of 15, 30, and 45. If we think back to the steps I taught you, the first thing we want to do is determine the product of prime factors. So we've done 15, and 15's product of prime factors is 5 times 3. Then we're going to do 30. I like to write the ones that are the same underneath each other, just to make it easier for myself when I have to find the groups. And then finally 45. Right, now I have to go and make the groups. So all 3 of them have a 5 and all 3 of them have a 3. Therefore, the HCF of 15, 30, and 45 would be 5 times 3, which is equal to 15. All right, wonderful. Now, the next thing that we can use our product of prime factors for is our lowest common multiple. So that would be if I had to keep counting in a number. So the multiples of 12, for example, would be 12, 24, 36. So it's when I'm counting in that number. So the lowest common multiple is when I want to know if I had to keep counting in both of the numbers that they're going to give me, what would the first number be that they would both share in terms of a multiple? So once again, we can use our products of prime factors to determine this. So let's say we want to know the lowest common multiple of 12 and 15. My step number 1 is still going to be to get my products of prime factors. So I'm going to start with 12. And then I'm going to do 15. So with the previous one we made groups. Now we are not going to make groups. We are going to write down all the prime numbers we had as answers. So if we go have a look, there was a 5, there was a 3, and there was a 2 that came up as prime numbers that divided in here. And then my third step is to make the biggest groups. So I'm going to go look at the line that has the highest number of each of them. So this one is the only one that has a 5, and there's only one of them. So I'm going to keep that 1, 5. Both of them have got 1, 3, so the 3 is going to remain just a singular 3. And then my 2's, there are 2 2's in one row. So therefore, to get my LCM, I'm going to say 5 times 3 times 4. So that's going to give me 15 times 4. That's going to give me 40 plus 20. So my answer is 60. That is the lowest common multiple for these two numbers. Now let's try it with numbers that are a little bit larger. Let's take 24 and 36. Right, so remember, the first step was to go and write it as products of prime factors. So 24 and then 36. Right, then remember, the rule says we have to go and write down all of the different prime numbers that we see as answers. So we have 2's, we have 3's, and that's it. We just have 2's and 3's. So now we have to find the row that has the most 2's. So it would be this one. That would be the row with the most 2's. And altogether, there are 3 of them. Now I have to go find the row with the most 3's, and it's going to be that one. There are altogether 2 3's. Whoopsie, that's supposed to be a 2, sorry. All right, now all I'm going to do is I'm going to multiply these two together. And my final answer is going to be 72. All right, guys, I hope that helped, and that is all for today.